Hey guys, BuildZoid here, and we're back with the Gigabyte RTX 3090 Vision. The card is not repaired, but it is in a functional condition, as in I can turn it on. And we're going to do a sort of like basic health checkup on the card that just like all of the silicon works, because obviously it had a V-core power delivery failure, which can sometimes kill the core, but usually the core isn't super likely to die in a VRM failure scenario. And then the memory VRM failed, which has a tendency to very reliably kill memory chips and memory controllers. Not that that happened to this card, which basically, like, props to Gigabyte on the the size of the fuse that they have on the PCIe slot, because that fuse actually protected the memory, right? Because yeah, so that's pretty cool. Because like I've seen quite a few GPUs where like the memory VRM dies and all of the memory chips are dead. And also the memory controller of the GPU is dead as well. And then like you need a whole new GPU because the memory controller is part of the actual core itself. So if that dies, you need a new core, which is literally worth more than the whole card. Like everything else, like the core is worth more than everything else on the card. So you may as well go buy a new card at that point. Anyway, so yeah, so the card survived thanks to the fuses. This is why fuses are good. However, as I said, it's functional, it's not repaired. And the reason it's functional, not repaired, is because I did try to replace the memory power stage, but evidently I still suck too much at hot air soldering because the card did not run when I had the fourth memory VRM phase enabled. So either there's something, like either I cooked the power stage trying to attach it to the card, which isn't super unlikely because 3090s have like a ridiculous amount of thermal mass in the PCB. It takes forever to like do any hot air soldering or really any kind of soldering on these cards without a ton of preheating. And even with preheating, it takes a while to really get anywhere with these with soldering on these cards. So yeah, I probably cooked the first the first replacement power stage. So I took that off just so that I could check that the card actually works. And I'll have to just, put it on again, except this time probably preheat the card more and try not to cook the power stage again, because I'm pretty sure that I cooked it, or I just didn't mount it properly. It might have been like one of the pins might have not connected. The thing is, the PCB on these is incredibly dense, and that just makes it really annoying to work on them. Because yeah, there's very little space to maneuver because there's just components freaking everywhere. Anyway, and then the V-Core VRM is also not fixed because the V-Core VR, like the fuse for the 8-pin power connector, unfortunately didn't fully do its job, right? So this is a tweet from me. And a bit of the high-side MOSFET welded itself, or actually I think that's the entire high-side MOSFET welded itself to the card. So that needs to be ground away, which I have like zero experience doing on GPUs, so I'm gonna have to like dig through my collection of I'm gonna take some of the dead cards in my collection and do like a bunch of precision grinding practice on those before I try to grind that away on this 3090, because the way you would fix this is you basically grind away the welded on MOSFET, and then if you do it properly, you can actually grind it away so that you only leave like the copper of the 12-volt pad that's under that MOSFET, and so then you can just replace it. At least in the theory, that's repairable. Otherwise, if I fail at doing that, the card will have to run with one missing V-Core phase, which means I'll probably be swapping one of the shunt resistor for that part of the VRM. I'll probably be swapping it out to like a 7 milliohm or something, so that the card doesn't so that the power limit for that portion of the VRM is lower, because yeah, that's not great. Like, this VRM already has the tendency to blow up when it has all of its power stages, and when it's missing one of them, it's just that much worse. So, hooray for 3090s. Yeah, so that 20 amp fuse on the PCIe slot unfortunately wasn't fast enough. Which kind of, I'm kind of surprised by that, because the other 3090 Vision also had a power stage failure in V-Core, and it didn't weld itself, so... yeah. Also, one of the things I've been wondering about with fuses on GPUs is, would it be at all practical to try have a fuse before each individual power stage? Because if you could have a fuse per power stage first of all, troubleshooting would be so easy, right? Like, you wouldn't need to do anything. Like, you would literally know immediately which power stage failed based on which fuse failed. But also, you could have much lower current fuses, because each power stage is handling only a fraction of the total current that the card is pulling. Now, the main concern I have with that idea is that power stages don't pull a continuous amount of current, right? Because they switch on and off, so they pull bursts of current, and I don't know how well fuses would play with that. I guess you could maybe have some input filtering and then the fuse, so that the fuse mostly sees like a DC current instead of the actual switching current that the power stage is pulling. Yeah. Anyway, so the 20 amp fuse on the 8-pin, unfortunately, in this case, wasn't quite enough to prevent the high-side MOSFET from welding itself to the board. It did, however, prevent the high-side MOSFET from burning a hole in the PCB, so that's still nice. Like, this is in the grand scheme of VRM-caused PCB damage, this is relatively minor, right? Like, this is really not that bad, because a lot of cards, you'll have a power stage that just burns a hole all the way through the card. So, yeah, the fuse still mostly did its job, and this is a lot better than having an actual crater in place of the power stage, because if there was a hole there, you're not replacing it, right? Like, it's a hole. So, anyway, back to the card. So that's why it doesn't have that's why it's not fully repaired. It's just like on one, so with the memory VRM, I evidently suck at hot air soldering, and on the VCore part of it, I'm not trying to grind away a high-side MOSFET on a 3090 just yet, because I'd prefer not to accidentally make a hole. Like, the VRM didn't manage to do that. I don't need to make it worse. So, anyway, but we can still do some basic checks that, like, the card is able to run at, like it's able to run something, especially that the memory can run at, like, full speed. And so to that extent, we're obviously going to crank up the fan speed, right, which we're just going to max it out. Also have the power limit set kind of low. The idea behind this is basically if you throw more cooling at the VRM, even if one of the power stages is missing, it shouldn't blow up, especially since we have the reduced power limit. So we can do a basic check that, you know, the card can actually run 3D load, because the main concern is, like, if you have a VRM failure, you can end up with the card being completely unable to actually run anything, even if you, like, fully restore the power delivery. So, yeah. So we're just going to run Firestrike Ultra, and I'm also going to throw, like, super sample anti-aliasing on this so that it uses a lot of GPU memory. We're going to window it. Oh, they don't have super sampling. Oh, that sucks. Okay, we'll just max out the MSAA. And maybe crank up the resolution a bit. Should have also pulled up GPU-Z. Yeah, so you can see 3090 detects all of the memory. It's also quite loud with the fans at 100%. Anyway, the other thing I wanted to talk about with this card is that, like, I saw a lot of comments on the initial diagnosis video from people saying, like, oh, it's always Gigabyte cards, and I don't really think it's like a Gigabyte build quality issue. I think the main reason that I've had 2 different Gigabyte Vision cards on the channel is because Gigabyte's RMA policy is super strict. Basically, if you bought a Gigabyte card from a scalper, they are not going to honor the warranty on it. Like, they don't have a... Like, their policy is that the warranty is not transferable. So, if your card up and dies, and it's a Gigabyte card, and you bought it from a scalper, well, you're basically, like, Gigabyte's going to reject your warranty claim, and your only options are to either fix it yourself or find somebody else to fix it for you. Or I guess flip it for parts on the second-hand market, because yeah, like, it like, Gigabyte's not going to deal with this, which is, you know, awful, but I'm not sure that, like, well, yeah, like, that just sucks. So basically, don't buy Gigabyte cards from scalpers if you want to have a warranty, because it's not transferable. Anyway, And yeah, so I don't think this is a case of like these Gigabyte cards having like a massively higher failure rate than other 3090 models. I really think that the other, like EVGA, when, you know, FTW3s were blowing up trying to play Amazon's New World, like EVGA basically went like, hey, we're going to replace any 3090 that died in New World. And so I'm never going to see one of those cards, right? Because why would anybody send me a dead FTW3 when EVGA is just going to replace the card for you if it died? So all of those cards went back to EVGA probably, and you're not going to see them showing up in repair videos on YouTube because, you know, that. And I think the same is probably true for a lot of the other manufacturers, right? Like, I don't, like, VGA is the one that, like, generally everybody says always has the, like, EVGA. Most people say that EVGA has, like, the best RMA policy. I don't know. I've never had to deal with it. So, yeah. I don't know how true that is, since I never had to deal with it, but, yeah, like, I think that's the main reason you probably won't see a lot of EVGA cards, you know, people trying to repair like 3090 EVGA cards because EVGA is replacing them. Anecdotally, I remember seeing a bunch of dead high-end MSI cards. I don't remember if they were 3080s or 3090s on UK eBay. The main reason you never saw those on my YouTube channel is because they were like 400 quid for a dead card, which... like, I think MSI put fuses on those cards, but I'm not 100% certain, and I'd rather not accidentally buy a brick, right? Like, I am willing to spend entirely too much on dead GPUs, but 400 quid on a potential brick is too much even for me. So, yeah, that's another thing, is, like, I really think the main reason these seem to be showing up a lot as, like, you know, in repair videos is because Gigabyte rejects the warranties on them. Which still sucks, right? Yeah, like that's still terrible, but I don't think it has anything to do with the actual failure rate. I really think it just has everything to do with the warranty policy. And at the very least, the fuses did their job, right? Like the card actually runs 3D loads that loaded up, you know, 4 gigs of memory. I'm fortunate. I guess we could try Unigine superposition. The thing with Unigine superposition is that while it is probably the best, well, it's the heaviest workload I've found that isn't New World. But the thing is, it doesn't let you run it windowed, which is really annoying because we can't use the monitoring, and the monitoring built into the benchmark is terrible. That's... I wanted something that uses like a ton of memory. Okay. It's going to run at snail speeds. Anyway, oh wait, I probably set it to 30 minutes. Oh, that's fine. Yeah, so the card exploded. Well, where was I going with it? Right, so the fuses did their job, mostly. The one on the 8-pin didn't prevent the high-side MOSFET welding itself. I suck at hot air soldering, which is why the memory VRM is still not fully repaired. Gigabyte's warranty policy sucks. And, what else is there? Oh, 3090s suck. Like, this is the one thing I always wonder about with, like the first 3090 I repaired. This was one of those things that I was wondering as I was repairing it, is like, what is the point in replacing a failed power stage with another one of those same power stages, right? It's kind of like, imagine if your car had, like, wooden suspension components, which break, right? Like, let's say, like, some suspension component on the left side of your car breaks. So you replace it with another OEM wooden suspension component, and then the right side breaks. Because, like, the problem isn't that the parts were old or something, it's just, like, they're bad. And so that's the thing that I wonder with 3090s, is just, like, how, like... am I going to, like, is this car just going to up and die again? Because, like, to me, it would make a lot of sense that it would just kind of do that. And I really think a lot of the 3090s that are failing right now are just the really unlucky ones. And over time, the failure rate's just going to keep going up. Because it's kind of like 980 Ti's. Like, 980 Ti's, when they first came out, I'm not a fan of the power delivery on 980 Ti's. But when they first came out, it wasn't like they were dying left, right, and center. But after a few years... 980 Ti's, you know, like, there's especially some EVGA models which absolutely demolish themselves because not only do they have the crappy reference VRM, they have worse cooling than the crappy reference design. So the VRM likes to explode far more often than the reference cards, though the reference cards also like to blow up. But the EVGA ones are especially common. Like there used to be so many on of those on UK eBay, where I think every single one of them probably had a VCore or memory power delivery failure, because those cards are terrible. But it took several years for that to really, start being like, yep, these cards really suck at staying alive. And there's other cards like that. There's like EVGA GTX 970s with a really miserable 4-phase VCore VRM, and recently those seem to have been finally dying a lot, which is actually not that bad. Like those cards are like 7 years old at this point, so that's a better lifespan than a lot of 980 Ti's right there. But yeah, that's sort of the thing that I'm wondering with 3090s is like the failure rate's probably just going to keep going up over time. And I'm not sure how much point there is in replacing, the components when it's just like, I mean, it died once. Why wouldn't it just die again? Why wouldn't just a different power stage on the same card die, So, also, especially because the first 3090 Vision had, like the VCore VRM failures are different parts of the VRM. It's not the same part, right? Like, at first I thought, oh, maybe it might be related to the way the current balancing is set up or something. But like across 2 cards, I've seen 3 different power stages fail, like totally different locations. Like, so I don't know if maybe with a bigger sample size, it might turn out that there's like a very specific set of power stages that likes to fail, or it's completely random, in which case the VRM is just bad. And yeah. So anyway, but the card can run very intensive loads. I mean, we're obviously at 60% power limit, so it's not running at 100% speed, but it can run things. Whereas if the memory had, like, died or something, we shouldn't be able to run anything at all at this point. Anyway, also the other thing some people might be wondering about is, like, where do you get replacement parts? DigiKey. Ta-da! So this is actually really cool right now that, the thing is, so these are 53, are these in stock? No, these aren't in stock, which really sucks for me, because these are the actual exact parts that I need. Also, what I've only just now noticed with this card is that they're actually using 2 different power stages. So the memory VRM and the MS-VDD uses BLN zeros, whereas the, so 5312... Whereas the VCore VRM uses AOZ 5312s. And these are in stock. They're also kind of expensive, which is annoying. These are £2 a piece. I think these are the BKU0. Am I right? Yeah, this is the BKU0. So, yeah, unfortunately, the MS-VDD and memory VRM uses the BLN0, and unfortunately those aren't, like, available. Right? So, like, this is the BLN0, which is the 5311 NQI, and then there's the 5311 UQI, and this one's actually in stock. And the thing is, but this is a BLU0, and I'm not sure that there's any difference between these. They're probably interchangeable. Probably. I hope. Like, arguably, it should be okay to just use the 5312s for everything. Because they're pin compatible, and the VRM doesn't use the power stages for the current monitoring, at least as far as actually, maybe it does. But not in the sense, like, because these don't have a current sensing output. But like the controller, because some controllers will use the DC resistance of the inductor, and some controllers will actually use the DC resistance of the low side MOSFET. Which, yeah, I guess if it's using the low side MOSFET resistance, then actually using mismatched power stages would not be a good idea. I'll have to check how that's set up on the 3090. Anyway, yeah, so that's, like, you can get some of these parts on DigiKey right now. Also, oh, I didn't plug in the keyboard. Give me a second. There we go. I don't really want to heat up the room any more than I have to with the 3090. Yeah, anyway, where was I going with that? Right, yeah, so you can mostly get 3090 parts on DigiKey right now. I've not seen them anywhere else. And unfortunately, for the ones that like the BLN Zeros, the lead time is 42 weeks. So, yeah, this is not great. It's really not great. Yeah, anyway, I'll have to look into that if it'll be okay for me to just use 5311 UQIs. Arguably, you could just swap all of the phases, but that... I'd rather not do that, because that, like, these aren't exactly cheap, right? These are like 1.5 pounds a piece. Yeah, also, evidently I've already screwed up with one of them, so I'm not sure that I want to try do this multiple times, because, well, the thing is, after you replace one power stage, the board is already hot, so the next replacement is going to be a bit easier to do, but, yeah, I'd like to do the minimum amount of soldering necessary to fix this thing, so actually replacing all of the memory power stages is not something I like. I don't want to do that. Anyway, there. That's it for the 3090. So yeah, it runs. So the silicon survived. The fuses did the most important part of their job. The 8-pin fuse didn't do all of its job because there's a bit of high side MOSFET on the card now. But yeah. Also, 3090s suck. Like, if you have a 3090 with a reference PCB, I wouldn't run... I actually wouldn't... I would put it on a shelf and look at it, at how pretty it is, because these cards, like, I know I've had 2 GB cards on the channel, but, like, this is basically the same VRM as all of the other reference 3090s, except Gigabyte added fuses and also slightly better power stages for V-Core than what you usually get. So, yeah, anyway, that's it for the video. Thank you for watching. Also, man, this thing is so annoying to listen to. But yeah, thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description. There's also the AHOC Teespring store where you can pick up shirts, hoodies, posters, you know, the usual YouTuber merch. And then there's also my Bandcamp, where I post sort of like industrial metal background noise type stuff. So you might want to check that out. Links to all of that are down in the description. If you check any, like, you know, it'd be much appreciated if you check them out. That's it for the video. Thank you for watching, and goodbye.